So basically, voxels define quality of volume pyro, and for image it is pixel. So here I have this simple example to just check, and if I increase these pixels, you can see here this image is getting more clear. Right, so this is more clear now, and let me just use 300. Yep, this looks good. So here pixel define the quality of image. So similar, voxel define the quality of pyro volume. But main point here, we need to understand how to define voxel, pixel over here, right? So this depends on distance as well. And if I just reduce this pixel, and if I check this, if it was in this distance, it's totally fine. We don't really need that 300 pixels, and here we can even optimize this, and there is too much distance like this and totally fine, right? And if I go more closer over here, and I need to increase this. So why I'm talking about this distance, the same concept applies in voxel as well. So this was the example of pixels, and let's just check out voxels as well. So voxel is also like 3D basically, and you can see here this is voxel size, and if I reduce this, and don't worry, I will talk about this in some time, but for now let's just visualize this. If I reduce this, you can see here that we are getting proper shapes over here. Void 0, let's use 0.1, right? So if I reduce this more, the more cube it will add, and it will define more clear shape. And let me just reduce this. Yep, this looks awesome, and proper shape it's taking, right? Check out this, we have clean edge, right? So but if I increase this, you can see here that we have some voxels. Along the way, we will learn how to choose correct voxel size. We won't waste any voxel, and based on distance only we will figure out how to choose correct voxel, right? So these are the similarities in pixel and voxel, right? And now let's understand this in more depth. If I middle click over here, that I have this point, primitive and peg geometry, right? So I don't want this hammer, so let me, as it's pegged, so I will just unpeg it, right? So it's unpegged, so I have proper numbers of primitive, vertices and polygons. So this is geometry, and how do I convert this into a volume? So for that we have these two options. So one is Houdini's default volumes. You can see here it's not clearly visible, so let me press D, and for while working with volumes I prefer using dark background, and I will keep this as a default only. So save as default, it will be saved, and now you can see here it's clearly visible, right? So as I have mentioned, this is Houdini's default volume. So if I middle click that, I can see some voxels, voxel size and its volume. So the name is not defined yet, but here I can just type this name. For volumes, we will work on this density. And now if I middle click that, I have this name. And how do I increase the quality of this volume? So for that I have to increase this. And yep, let me increase this 100. And let me use 200. As you can see, it's taking time, and we don't have very clean volume as well. So the good thing is we have other options as well. So as this was Houdini's default, so other option is VDB. So here if I go that, I have that option VDB from particles, VDB from polygons. As these are polygons, so we will use VDB from polygons. And let me check this, connect this. So it gives two options, distance VDB and fog VDB. So this distance VDB, we will talk about this later, but for information, we will use this for collision. And here I'm interested using in fog VDB. And let me just reduce these voxels. You can see here, this is really quick, and we have more better over here. So as you can see, VDB is more faster, right? So for source, we will use VDB only. And next we will talk about pyro source.